All right, part A, does f have any relative extrema? It will if the first derivative is 0. So when we set this equal to 0, x is either equal to 2 or 4. So are these relative extrema? Let's make a side chart. Label the axis x. Communicate that we're indicating the sign of f prime of x. Our critical values are 2 and 4, and now we'll find the sign of f prime of x in each of these three regions. If x is, for example, 0, then we'll have a negative times a positive times a negative, which will be a positive. If x is, for example, 3, then we'll have a negative times a positive times a negative, which is still positive. And then if x is, for example, 5, then we'll have a negative times a positive times a positive, which is negative. All right, then by the first derivative test, if the slope was positive and then negative, we will have a relative maximum at x equals 4. Positive slopes and then it becomes a negative slope, there must be a relative maximum there. All right, how about part B? On what intervals is f decreasing? Part B, we know a function is decreasing when its derivative is negative. So when is f prime negative? Well, we can see from our sine chart from part A that the derivative is negative when x is greater than 4. Or in other words, on the interval from 4 to infinity, open. All right, how about part C? On what intervals is the graph concave down? So for that, we'll need second derivative. So taking the derivative of the first derivative will give us the second derivative. So we'll take the negative constant times the derivative of the variable expression part. We use the product rule, simplify this to that, and then combine like terms, and we get this expression. And the function will be concave down when that second derivative is negative. And this expression, the second derivative, is negative when the quadratic factor in black is positive, because a negative times a positive will be a negative, less than 0. I'm going to guess this is factorable. And it is factorable, which is great, because now we can determine when the second derivative, right here, when it's negative. It's negative when this is positive. Let's get a number line and find these critical values. This is equal to 0 when x is 10/3, or about 3 1/3, or when x is 2. And so these regions will have uniform signs. When x is less than 2, for example, what if x is 0? Then we'll have a negative times a negative, which is a positive. Let's write that out. And then when x is between 2 and 3 1/3, how about the value 3? We'll have 9 minus 10, which is a negative, times a positive will be negative. And then when x is bigger than 10/3, like let's say x equals 4, then we'll have positive times a positive, which will be positive. Remember that you will be missing points. Your score will be reduced if you don't label what's happening here. So the number line are values of x, and the signs are the signs of this expression, which we need to be bigger than 0. All right, there we have it. F is concave down when the second derivative is negative, which happens when x is less than 2 or greater than 10/3. Or in interval notation, x values in the open interval from negative infinity to 2, as well as the x values in the open interval from 10/3 to infinity. Finally, part D. How many points of inflection does the graph of f have and where do they occur? So for this, we want to know when does the second derivative equal 0. We had already calculated the second derivative in part C, so let's set this equal to 0 and solve. So we have these values when the second derivative is 0, when x is 10/3 or 2. But it's not an inflection point unless the concavity changes from up to down or down to up. So let's see what the sign of f double prime is. When x is less than 2, like 0, the sign of the second derivative will be negative, because negative times negative times negative is negative. When x is between 2 and 3 1/3, for example, if x is 3, we'll have a negative times a negative times a negative, times a positive there, which means we'll have a positive value. And when x is bigger than 3 1/3, like 4, we'll have a negative times a positive times a positive, which is a negative. So indeed, the concavity changed at this point, making it an inflection point, and it changed here as well, making that an inflection point. We have two inflection points, and they are when x is 2 and 3 1/3.